Hello guys, it's me Sanjay here. Welcome to Pantech Solutions and then Warriorsway. And I'm warmly welcome you all for the series A.I Masterclass Day 10. So I hope you guys all super enjoyed up to now like 9 days of series. And I hope you guys all ready for the today's session because today's session is really important under the category of deep learning. Why? Because today we are going to be covering up with especially on convolutional neural network and how it is working and what's the process, like what each and every layer will do, and we are going to go a little bit in depth on application basis, so how it is going to do the classification and how it is going to work. And today we are going to little bit detail exploring the CNN, but the project which is based on normal multi-layer perceptron. So that is what the today's session is about. This session is very important session because we guys have covered up how everything is working, like how the new numbers are which has been processed, how it is being analyzed. So likewise we are going to process lot more stuffs. Okay, so those are the stuff we are going to carry out in the session. If you are super excited for the today's session as well, we just post I'm super excited Sanjay in your live chat. So thank you so much guys. So before that, I really wanted to welcome the people present here. The first message, which is by Benamazagia. Good to meet you. Great. Benamazagia, you've been connected with me for a long more session. Thank you so much. And Manas, hi, good evening. And Apikunda, hi. Nirisha, hi. Shruti, hi. Amisha, hi. Pavitra, hi. And Sneha says, hi. And Dedarul Hasan, hi, sir. And Jacqueline, hi. Gokila, hi. Tangambel, and Kevin, and Israel. And Anand Kevian and Kevin Ogutu and Salman Khan and Tolulope and Israel and Archana, Ravikumar, Raunek, Chandramohan and ADM and Crunch Cracker and AVB, Rajshekhar sir and Ifam. Hello guys, good evening everyone. Thank you so much for your warm welcome guys. Prabha, waiting for you Sanjay. Thank you so much Prabha for posting that. And Priyanka, hi, good evening. And Purvesh, hi, good evening. And Saktish Varan, hi, good evening. And Janesh, hi, good evening. And Sasi Devi, ma'am, good evening, ma'am. And Niveda. So, hello, guys. Thank you so much for your warm welcome. Thank you. Thank you so much for your happy greet now. So, let us begin the session. So, first of all, we guys have talked about a neural network, right? So, here we are just seeing the picture. Which we are just visualizing a normal neural network. Okay, it is not like an involution, just a normal basic neural network, which it contains three layers: input layer, hidden layer, and output layer. So yes, so let us have some interaction now. Okay, you guys tell me what is the purpose of hidden layers. Okay, it is gonna be a very easy question. So you guys tell me the answer. What is the purpose of using hidden layers? What is the purpose of hidden layers? What the hidden layer actually will do? So that is my question. You just give your answers in the live chat. So while talking about the neural network, it is being formed or it is being framed by grouping some of number of neurons which serve some of the purposes. For an example, it is going to have some of the neuron which is being grouped together to form an input layer, and some of the neuron is being grouped together to form a hidden layer, and some of the neuron is being grouped together to form as like output. So it may be like single neuron or multiple neuron based on the how much class you have. Here, while talking about this network, so neural network, right? So while talking about the network, it is gonna be like every neuron which is present in one layer is being connected with every neuron which is present in the next layer. Abhishek Kumar, hi. Okay, I told your name. And the first answer which is being given by Kalis Bala, extracting features, exactly. And Pavitra, and Josie, and Niveda, and Vijay, and Gomati, wonderful answers guys. The exact answer is extracting the features, exactly. So while talking about this neural network, it is having some neurons present in layers. So each and every neuron which is present in one layer, which is going to be connected with each and every neuron which is present in the next layer, right? So it has an interconnected input and output in which each connection has an associated weights. So as I've already told you, you can imagine this lines as a weight. I hope you all remember that. Right? If you all remember that about weights, you just post I remember Sanjay in your live chat. Okay, so yeah. So while talking about this, so here we have the first neuron to the first neuron in hidden layer, first neuron to the second neuron in the hidden layer. So likewise, every neuron is having interconnection with another neuron in the next layer. So this is being called like here, you can imagine these lines are going to be our weights. Okay, so it is the interconnected input and output in which each connection has an associated weights. it will adjust the weight during the learning process. Okay, so while talking about the perceptron, so what is mean by perceptron? Only input and output layer, there is a no hidden layers. That is known as a perceptron, and which it has some which is going to be useful for only some decision making. Okay, basic decision making. I think you can able to see in the picture now. Okay, this is the neural network, and below here we have a perceptron, which is very simple architecture. So that is what this neural network and perceptron is. Now, while talking about this deep learning, here the first neural network we have is artificial neural network and recurrent neural network and convolutional neural network. As a basic stage, I can give some basic example, okay, because we are not going to what is it? I'm not going to go very in depth now, so I'm just going to give some basic example, just to remind that. So while talking about ANN, which is suitable for solving some numerical data. Okay, for an example, if we are having Excel sheet, so some of the basic like some of the basic application can be done with the help of A and N. And then recurrent neural network, which is suitable for the recurrent connections. For an example, so let us discuss later. So first of all, ANN and RNN and CNN. So while talking about this ANN, you just see this architecture, which is the same picture which we guys have explored before. So which learns non-linear function. It is also known as universal function approximators. And it is completely like feed-forward neural network. So what is mean by feed-forward neural network? It's simple, guys. Whenever you are giving some input, it is not going to have any recurrent connections. It is not going to have any feedback. It is not going to worry about whether we got this output or not. So it is moving towards the forward position, forward direction. So that's why this network is also been called as feed-forward neural network. Okay, so this is a normal artificial neural network. Okay, so the activation function introduced non-linear property to the network, so it will identify the complex relationship between input and output. This is the normal and basic form of the neural network, guys. An output of each neuron is the activation function of weighted sum of an input. So this we will learn later. So just see the picture, how it is looking like. Okay, just please focus on the picture, guys. Okay, so this is ANN, which is having these layers, and every neuron is being connected with every neuron on the next layer, and which is completely feed forward. It is not having any feedback or any recurrent connection. It is completely feed forward. And so these are the basic neural network, guys. Okay, are you clear with the first part? If you are clear with the first part, you just post I'm clear now, Sanjay. Clear one, Sanjay, in your live chat. And second thing, you can able to see the difference, I think. So you just tell me what is the difference between this ANN picture and this RNN picture, guys. Thank you so much, Abdullahi, for posting. Very interesting, Sanjay. Thank you so much. Thanks a lot. Okay. So you just see the picture. This is what ANN looks like, and this is what this RNN looks like. I think you can able to find out the difference between this ANN and RNN. Right? You just see the picture carefully. Okay. You just give me the answer. So while talking about this structure, looping system in a hidden layers of ANN, which is known as recurrent neural network, which is known as RNN. It captures sequential info of input data, that is dependency between words to make prediction, whereas ANN cannot capture sequential information. Because as we guys have already learned, while talking about this ANN, which is completely feed forward, it is not going to have any recurrent connections, it is not going to have any feedback. But while talking about this RNN, it is having that feedback facility or ability so that it can track the previous statement. For example, I'm telling like if you are talking to a chatbot. So for an example, if you ask like what is the time now? Okay, so that is your question. So what is the time now? So if your word is not clear, okay, if your word is not clear, like if you are pronouncing like what is the time? Okay, so like what is the time now? So likewise, if the last word is not pronounced properly, okay, I think God is really it is really getting interest for you, right? So if you are still interested, if you are really enjoying, you just post I'm enjoying Sanjay in your live chat. So whenever you are speaking to that kind of voice assistant, for an example, if your statement is what is the time? Okay, so if the last two words which is not being pronounced properly, what that need to do is it need to analyze, even though that is not pronounced properly, that need to match that audio frequency with the matching words, of course. So here another main thing which it can do is it can analyze the previous statement to predict the future statement. So I think whenever you used to go for the Google and if you are typing something, okay, for an example, if you are going into this Google, and whenever you are going to type something. Okay, so for an example, I'll type now. Just see here. Okay, you just see here, while talking about this kind of statements. So you just see here, whenever it is giving, like whenever I'm just typing like ARTIFI, it is predicting the upcoming information with the help of the previous statements, right? So on that purpose, or on that way where this RNN is gonna work. Okay, that is where it is gonna be really helpful. Okay, I hope you clearly understood how it is working. Okay, recurrent neural network, which is the looping system in the hidden layers of ANN, is known as RNN, and it captures the sequential information, and RNN shares parameter across different time steps. It is the time series version of ANN. Common recurrent layers are LSTM, which is long short-term memory, and graded recurrent units, and it is mostly used in NLP applications. So it is going to be helpful for creating a chatbot. It is going to be helpful for predicting the upcoming statements with the help of the previous statements. So that is what it is going to do, guys. Okay, I hope you are clear with this RNN. If you are clear with RNN now, you just post clear Sanjay in your live chat. You just post clear to Sanjay in your live chat. Okay, now we are moving on to the third very important network, which is CNN. So this convolutional neural network is mainly focused on processing images or video, guys. Okay, so CNN learns the filter automatically to extract the right features from the data. As we guys have already learned, in this deep learning, it is having a facility to automatically extracting the features. This CNN is going to do that. So it captures facial features, whereas ANN can't. For an example, so before that, we'll proceed further. So it also follows parameter sharing like R, and then apply single filter in different part of a single image. So for an example, okay, so you just imagine this is a picture. Okay, you just imagine. Okay, so let us take some other boards. Okay, so you just imagine, guys, this is the picture. Okay, you just imagine this is a picture. So in this picture, it is having that what is it? Spatial. It can able to capture this spatial features. For an example, if this is the picture, whenever you are converting into a digital format, whenever you are capturing with the camera, whenever you are capturing with the help of mobile camera, anything. So it is nothing but it is gonna have that rows and columns, right? So digital image is nothing but it is got a combination of pixels which is in the rows and columns. Okay, so which is like a matrix. For an example, if it is in the dimension of 24 cross 24, which is like 24 rows and 24 columns of pixels is gonna be there in this picture, right? So with the help of the CNN, what it can do is it can process the image bit by bit. For an example, instead of processing 24 cross 24, it can process 3 cross 3 matrix. Okay, it can do. Okay, the CNN can especially do. So it can process the 3 cross 3 matrix, and it can apply some filter on it, and it can give us the output. And then it is going to take second 3 cross 3, apply filter, give us the output. Again, it is going to take third 3 cross 3 and apply the filter and give us the output. So likewise, it can play with the features, okay, spatial features. Okay, so it don't have a recurrent connection like RNN. Instead, it has a convolutional type of hidden layers. It is not gonna have recurrent connection of connection, whereas it is having the it is having a convolutional type of architecture, and the activation functions. While talking about activation function, yesterday I think I told some of the activation functions are there, like a convolution layer, pooling layer. It is having a lot of functions are there. While talking about some of other activation functions, these are layers, guys. This is not a like you can call it like function, but while talking about the layers, there are a lot of layers like ReLU and softmax, sigmoid, and etc. While talking about this convolution, you just see here input image and other as a filter on input image produces output image, and pooling. So we'll see later. Just see the architecture, guys, how it looks like. Okay, previously we guys have seen the picture of ANN. We guys have saw the picture of RNN. Now you are seeing the architecture of CNN. How it looks like. Guys, are you guys really enjoying the session? If you all enjoying, if you all still with me, just post I'm with you, Sanjay, in your live chat. There are a lot of people have posted clear Sanjay, and I'm enjoying. Thank you so much. Thanks a lot for doing this. And please call me Sanjay, guys. Don't call me sir. Okay? Yes. Just see the picture. Same as like as I really wanted to explain in the normal way. So 3 layers: input, hidden, output. So this layer, which has been called as input layer, I think you can able to follow my mouse pointer. This is going to be called as input layer, and in between these layers are known as hidden layers, and finally it is going to have an output layer. Okay, so in this project, this picture, what it is representing is it is doing handwritten digit recognition. So that's why input image 2 digit is given as an input. And in between, it is having lot of layers like convolution layer, maximum pooling layer, again convolution layer, again maximum pooling layer. As we guys have already told you, it is hidden. While talking about the hidden layers, it is not only mandatory to give only one hidden layers. It can have multiple hidden layers to extract more number of features. So that's why it is having more number of hidden layers to extract more number of features. For an example, if you are giving dog and cat image as an input, whenever it is passing one hidden layer to the another hidden layer, it can detect the edges, it can detect the tail, it can detect the mouth of the dog, it can detect the leg of the dog. So likewise, so it is going to be helpful for extracting more number of features whenever it is having more number of hidden layers. So these are the picture where it is input layer and like list of hidden layers are there, and finally there is output layer. So you guys tell me if you guys have any guesses. Okay, if you don't have the answer, don't worry. Give the wrong answer, guys. Okay, so if you really don't know the answer, give the wrong answer. Okay, don't just I really don't know. Okay, don't tell like that. Try it out. Okay, check it out. So what are the possibilities are there? Just tell me in output layer how many neurons gonna be there. You guess. Okay, guess it, guys. I'll tell the project what the project we are working on. We are working on the project called handwritten digit classification. So that is what we are going to work on. Okay, handwritten digit classification. That is what the project we are going to work on. So you guys tell me what is gonna be or how many number of neuron is gonna be in the output layer. Because we already know output layer is responsible for representing an output. So that is what my question is. You just give your answers in the live chat. Okay, so input layer, hidden layer, and output layer. Okay, so yeah, a lot of people are responding the message 8499. No guys, no. Do you guys, can you guess it properly? Because I told you the project is handwritten digit recognition. It is not a character or alphabet, it is a digit recognition. You just guys guess it, how many neurons are there. Some people are seeing the picture and they are just telling the neuron is gonna be 4, but not. I've just dropped some etc here. Yes, we got the first right answer by what is that name? Nana something. So NAA, some name is there. So who is that person who given the first and right answer? Yes, a lot of people are started giving. So Hemant, yes, and Pushpanjali, yes, right answer. And other people, don't worry. Sai Avinash, yes. Hamadan Diarrhea, thank you so much. Yes, the answer is 10. Why? Because the project is digit classification. So 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Okay, so which is 10 neuron is gonna be there, guys. Okay, so sorry, it is not gonna include 10, right? So 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. So totally 10 neuron is gonna be there on the output layer. So if this neuron has been activated, the output is 1. If this neuron is activated, the output is 9. If this neuron is activated, the output is 0. So that is what the CNN architecture, guys. I hope you really love this. You just, if you really love this, you just post "I love this, Sanjay" in your live chat. Okay, so do you guys really love this? Okay, these are all very small stuff which I am explaining here, guys. In internship, guys have explained very in detail because we guys haven't have any timing constraint there. So we guys have explained very detailed on the internship. Please register for the internship to get the detailed value. Okay, so then you can also see the video again as well. So today we are going to be exploring softmax function a little bit. Okay, I'm not going to cover up very in detail. So first of all, let us see the formula. For an example, if you want to predict something, so y is equal to, so if so in that on the list of lot of activation function, here we are just exploring a softmax activation function. So while talking about the softmax, here we have this exponential of ln divided by modulus of ln. First of all, while talking about L, the formula is product of x and then w plus b. So see, what is mean by this x? What is mean by that w? What is mean by that b? It's simple. X is gonna be your input. W is gonna be your weights, and B is gonna be your biases. Are you clear? Thank you so much. Rishikesh, please call me Sanjay. Hitesh, wonderful. Thank you so much. And Arisha, thank you. And Kevin, thank you so much. And Israel, okay, wonderful guys. Thank you so much. Okay. You just see here, as I've already told you. So it is like product of input and then weights plus biases. That is what I've told you. So just imagine this is my picture. Okay, so 2 is my digit picture. I'm going to give us an input, which is in the dimension of 28 cross 28 cross 1. Okay, if it is 3, that is going to represent a color image, RGB. If it is 1, so that's why it is going to represent a grayscale or binary image. Now you just see the picture, okay, picture where the expansion has been done. So what is mean by that? You just see this architecture, guys. Here I have included some statement called flattening. So I'll tell you now what is mean by the flattening is. This is the picture, as I've already told you. For an example, this board is in the dimension of 28 cross 28, right? Same as like this picture, you just imagine I've represented 28 cross 28, but I can't able to draw 28 rows and columns. So that's why I've given to understand it easily. I'm just giving 1, 2, 3, 4. So 4 rows and 4 columns. Sorry, 1, 2, 3, 4, 5. Okay, I've given 4 rows and 5 columns in this matrix, right? So 4 rows and 5 columns. So which is like 4 cross 5. So wow, this image is going to be flattened this, because this is like 2 dimension that need to be converted into a single dimension. How can we do that? It's simple. First of all, we'll take the first row. So 1, 2, 3, 4, 5. So 1, 2, 3, 4, 5. And we are going to take the second row, and it is going to be appended with this. And we are going to take the third row. We are going to append like this. And we are going to take the fourth row. We are going to append like this. Likewise, the image, the 2-dimensional image, which is being flattened into a single dimension. Are you clear? Okay, if you are clear, you just post "I'm clear, Sanjay" in your live chat. So here we guys haven't included any complex layer. We just directly passed an input image to the output layer. Okay, output layer, here we have 10 neurons. So 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. Okay, so likewise we have 10 neurons. Every pixel which is being present in this flattened area, which is being connected with every neuron which is present in the output layer. So that is what this simple softmax classification without any complexity. Okay, I haven't included any other hidden layers. I haven't included any other complexity. Simply I just take an input and applied softmax, where before that image which has been flattened and it has been passed into the output layer. So simply we are going to apply the formula or apply the equation, which is equal to y is equal to softmax of product of input and then weights plus biases. So that is what we are going to do. Okay, just see the picture now. Now this is for a single image. Okay, so let me answer. Let me ask another question. Do you guys have any guesses how this 784 got there? Okay, because here we have 28 cross 28. Okay, with 28 rows and 28 columns. This image, this 2-dimensional image, which has been flattened into a single dimension. So you guys have any guesses how this 784 pixels are there? So this is a 784. Here you have dropped etc. Right? So 784 pixels are there. You just give your answers in the live chat. How that is the 784? So here in this picture, we guys have did it for only one image. You just see this picture, we guys have did for 100 images. Okay, forget about these parts. Just see only this part. This is my input, guys. This is one flattened thing. Okay, one flattened image. And this is the second flattened image. This is the third flattened image, up to etc. 100. So which is like 100 images, guys. Yes, Anil Kumar given the right answer, and Gomati given the right answer. And Crunch Cracker, exactly, guys. Multiplication of 28 cross 28, that is 784 pixels. Same as like before we did for only one image, now we are doing it for 100 images. So that's why 1, 2, 3 up to etc. 100. So 100 images is going to be flattened like this. This is my X, guys. Okay, just see here. So softmax of product of X dot W plus H. X is going to be your input, W is going to be your weight, and B is going to be your biases. X is input. So what is mean by input? It is nothing but my image. So here we guys have used only one image, but here we dropped 100 images. So 1, 2, 3 up to etc. 100. So 100 images is going to be your input, which is going to be dot producted with the weights. Okay, weights are nothing but the lines which I have already explained you. So W01, W02, W03, W04, and W10, W12, W13. So likewise, it is going to represent the line. So that's why we are having another matrix of 784 cross 10. So here you can able to easily guess that why there is 100 cross 784, because there are 100 images which has been flattened into a single dimension of only columns. So where it has been, so that's why the matrix in the dimension of 100 cross 784. So you guys tell me how this 784 cross 10 came. Okay, so let us see who is going to give the right answer, guys. Okay, so the first person who is going to answer this question, I'm going to give one gift for the person. So how there is 784 cross 10? That is my question. You just give your answers in the live chat. So the person who is going to give the right answer, I'm going to give one surprise gift for the person. Okay, I'm just waiting for the reply. How there is 784 cross 10 matrix? Okay, so weights, this matrix is nothing but weights, which I've already told you. But how there is 784 cross 10? Okay, well, how there is 784 cross 10? Okay, so I just need exact answer. So let us see who is going to give the answer. I'm just going to wait, guys. I'm just going to literally wait for the person who is going to give the right answers. I really need exactly the right answer, guys. Don't simply put 10 weights or something like that. Okay, just give the line statement. Okay, kind of line statement when I've satisfied. Okay, so 10. Okay, it is not like 780 rows and 10 columns, not like that. No, I really need the exact answers. Okay, some people are giving near right answers. Okay, so I really need a line kind of statement. Just expand it. Okay, don't reply me in single word. Okay, just give me in a line of statement, guys. Okay, so 10 is output. Okay, guys, 10 is output. I really know how this matrix is being framed like this. How this matrix is in the format of 784 cross 10. Okay, I think some people are answering 784 cross 10 connections is equal to weights. I didn't get that, guys. Let me check. Yes, guys, lot of people are very near to it. Lot of people are given the right answer. This 10 is representing output. That is right. But I really need the line, a statement of the answer, why you are defining or how this matrix has been framed like 784 cross 10. Let us see who is going to give the answer which I am expecting. Yes, we got the right answer. A lot of people have given the right answer, guys, and I really sorry because a lot of people know the answer. They can't able to convey it properly, but I think Sai Avinash conveyed it. So each input has to match with all outputs, right? So by observing this picture, here we have 784. So each input means which is having 784. So each input has to match with all outputs. So each input is there. So this one is also one input, 2, 3. So likewise, each inputs are there. So each input has to match all outputs. So here 784 inputs are there and 10 matrix are there. So that's why it is being called as, or that is why it is being said to be in the matrix of 784 cross 10. Let us give the great applause for not only Sai Avinash and for also for other people who guys have given the right answer. Now there are a lot of people are giving the answers. 100 images, 784 pixels, 10 pixel, 1 image. Yes, a lot of people are giving the right answer. But let us give the great applause for the person who conveyed it properly, because in interviews you should have that skill. Okay, even though you know the right answer, you just want to be able to clearly convey it. Okay, let us give the great applause for Sai Avinash. Sai Avinash, you just please ping your mail ID to my LinkedIn so that I'm gonna be giving you one brain computer interface course for absolutely free. Okay, so I hope you guys didn't I think you guys didn't imagine that, right? So we are gonna be giving one course which is brain computer interface course absolutely free for Sai Avinash today. So I hope you really love this, Sai Avinash, and other people who also enjoyed it. I hope, I think so. So this is the course which we are providing usually at the price of 999 rupees, which I'm just going to provide this brain computer interface course absolutely free for Sai Avinash. So thank you so much, Sai Avinash, and thank you so much every people who guys have tried it. You are really great. So likewise, I'm telling you guys, please attend every day of the session. There are a lot of surprises which is really waiting for you. So these are the things. So let us continue the session. So these are the weights, and this is the dot product. So dot product of your input matrix and weight matrix, which is gonna give the matrix of 100 cross 10, which is like 784 got cancelled. So on our school days we used to, our faculty we used to say that, right? Just see here. 100 cross 10 matrix, and with that the biases is gonna be added. So that is what is all about, guys. Okay, so here what we have is 100 image at a time. So this is all about here. Now let us see in TensorFlow. While talking, so by using this, if we really want to use the softmax, that can be easily done or imported with the help of TensorFlow library. So TensorFlow dot neural network dot softmax of TF dot matrix multiplication of x comma y plus b. B is nothing but a biases, which is going to be helpful for an example whenever you are doing a dot product. For an example, if your images, if your input is 0, the dot product of 0 is going to be 0. So to overcome that, we are going to add another additional value, which is a biases. So that is what the formula is. And whenever it is returning, it is going to give us the probability values like this 0.1, 0.2, 0.9 kind of thing. So out of that, we are just going to maximize, or we are just going to find out which is having a maximum value. So from that, we found out like 0.9 is maximum when compared to other stuff. So that's why we can make a decision. The output is digit number 2. Okay, that is what this how it is going to work on that flow. Okay, this is like softmax and a feed forward, back propagation, gradient descent, and vanishing and exploding gradient. This is one of the major problems we used to face in deep learning. So this stuff which has been clearly explored on the internship, please attend the internship. Okay, so now let us learn some basic syntax, guys. Now we are going to design some multi-layer perceptron where it is gonna have hidden layers, and it is gonna be helpful to design a neural network for an example. First of all, what we are just going to do is we are going to use a syntax called model, so which is from the TensorFlow or Keras. So model dot add of dense of here 12. So what is the 12 is representing is the 12 neuron which is present in the hidden layers, whereas input dimension is equal to 8 represents is 8 neuron which is present in the input layer. Okay, so input layer and hidden layer. So 12 is going to represent 12 yellow color neuron, and input dimension is equal to 8 represent 8 blue color neuron, and in uniform and activation which it's going to use is ReLU activation function. So here you may feel some difficulty, Sanjay, what is meant by ReLU or rectified linear unit, and what are the argument which you are passing, and what is this dense means, what is the functionality. So likewise you may have a lot of doubt which is running in your mind, because this time is really not sufficient to explore a lot in detail. So definitely in the internship you guys have explored everything in detail, but now I can tell you, so this dense is going to perform this function, guys. This softmax, this product of input and then weights plus biases, this function is going to be carried out with the help of this dense. Okay, so input is going to have 8 neurons, and first hidden layer it is going to have 12 neurons, and second hidden layers it is going to have 8 neurons, and in the output we are going to have 2 or any neuron based on our requirement. And model dot compile. So first of all, we need to create, or we need to design our neural network, and we need to compile our model by using a loss functions like a binary cross entropy, or optimizer is equal to Adam, and matrix is equal to accuracy. I think definitely you know, you feel difficulties little bit. So but this is a binary cross entropy for that, because here today we are going to work on a project which is diabetes reduction. For the diabetes reduction, we are going to tell whether the person is having a diabetes or not having a diabetes. So to represent that, it is either having a diabetes or not having a diabetes, 0 or 1. So that's why the loss function is going to be binary, because that is 0 or 1. And optimizer is Adam optimizer. There are a lot of optimizer. Here we are using Adam optimizer, and matrix based on the accuracy is going to compile the model. So this is the syntax to add the layer. Here we guys have added for one hidden layer, one input layer, and one hidden layer, and another hidden layer, and output layer. So this is the layer we guys have added, and compilation which has been done, and we are going to save the model, and we are going to load the model. So this is what we guys have did from this program. Okay, are you guys excited to do the project today? So if you are super excited for the project, you just post RF get Sanjay in your lecture, ready for hands-on. Okay. Guys, are you guys ready for this today's hands-on? So what is the project we are going to work on today is, we are going to work on a project which is PIMA, Indian's diabetes reduction. So what we are just gonna do is, we are just going to detect the person's diabetes. We are going to clear the classification with the help of this neural network. So before proceeding further, before proceeding with the program and those stuff, I really want to explore the data set first. Okay, so let me show you the data set first. You just see the data set. In my data set, I'm having numerical values. So here we are not going to handle images, because on the upcoming session we are going to use the images. Now we are going to handle numerical data. So you just see here 1, 2, 3, 4, 5, 6, 7, 8, 9. So there are 9 columns in my data sets, right? So 1, 2, 3, 4, 5, 6, 7, 8, 9. So there are 9 columns of data set which is present in my here. Okay, is present here. So 9 column and 768 rows. So totally 768 rows and 9 column which is present in my data set. So in this data set, these are all some features. Features in the sense, the first number is number of times pregnant, which is happening for women, and plasma glucose concentration. This is plasma glucose concentration, and this one is diastolic blood pressure, and this one is tricep skin fold thickness, and this one is 2-hour serum insulin, and this one is body mass index, which is BMI, and this one is diabetes pedigree function, and this one is age of the person. So, and finally we have the class. So this is the data we have, guys. So out of that we can able to easily observe that this 8 columns is going to represent our input, and final column is going to represent the output, because in the final column it is having 1 0 1 0 0 something like that. So 1 means the person is having a diabetes, and 0 means the person is not having a diabetes. So that is what the data we have. I'm not going to go very in depth on the program, because which is given for the internship participants. But other than that, I can explore this source code little bit. Okay, you just see here what we just did. Okay, so I can show that code to you anyhow, but I'm not going to go very in depth because it is really huge. Okay, so not that much huge, but some of the syntax need to be learned. So first of all, we guys have imported the library. So this load text numpy, from numpy import load text. This is the library which is going to be helpful for loading the data set, because my data set, which is in the format of .csv. So you need to load the data set into your program. So to load your data set into a program, you need to have a library which is numpy import load text. This is a library. With the help of that, we are going to load the data set. And here we are using the framework. As I have already told you, there are a lot of frameworks like Keras, TensorFlow, Caffe, MexNet, PyTorch, and etc. So out of that, we are going to use the Keras. So from keras.models, import sequential. So what is all about the sequential is, this is going to be helpful for organizing your neural network in a sequential order. Okay, for an example, you are going to design this neural network, right? This simple neural network you are going to design now. So to design it, whenever you are adding a layers, it need to be organized in a sequential order. So that's why we are importing a sequential library. And dense, so which is going to perform that mathematical function, which is like product of input and then weights plus biases. And this library, which is going to be helpful for saving or loading the model. So that is what is all about the library. I hope you are clear with the library. You just post clear Sanjay in your live chat if you are clear with the library. So numpy for loading a data set, sequential for organizing the layers in a sequential order, dense for performing a mathematical operation in the neural network layers, and model from JSON, which is going to be helpful for loading the saved model. Now it's time to load the data set. So here to load the data set, we are using the library called load text of the data set name. So diabetes, Indians, PMA Indians diabetes reduction. So PMA Indian diabetes.csv, the CSV file name, and comma delimiter is equal to comma, because this is a comma separated value, which is the CSV, which is mean comma separated value. So that is the data set. We are going to load it and we are going to keep it in the variable called data set. What we guys have did is, we guys have read every data which is present in my data set into the variable called data set. Now, so I'll write the command again so that you will be understanding, I think so. Okay, so load the data into the data set variable. So that is what we did. And now it's time to segregate our data set. Okay, so segregate data set into input and output. So what is mean by that? As I've already told you, out of this data set, this first 8 column is going to be your input, and final column is going to be your output. So this is what the data you have. So x is equal to data set of colon comma colon 0 colon 8, and y is equal to data set of colon comma 8. So what is mean by that? So 0 to 8 means 0 to colon 8 means, which is 0 1 2 3 4 5 6 7. So it is not going to include the last number. So 0 to 8 means, which is going to include this 0 to 7 columns for input, and 0 colon 8, not like 0 colon colon comma 0 colon 8. It is like just colon comma 8. So what is mean by that? It is going to represent only the 8th column. Okay, 0 1 2 3 4 5 6 7 8. Okay, 8th column only. It is going to read the 8th column. So which is like x and then y. X is going to be your input and y is going to be your output. So data segregation is done. Now designing the neural network. So as we guys have already learned the syntax, so what we are just doing is we are just first of all initializing the model is equal to sequential, because we are going to organize the layers in a sequential order, and model dot add of dense of 12 comma input dimension is equal to 8 comma activation function is equal to relu. So I think you guys already know how it came. So we guys have designed the first input layer and one hidden layers. So that is what we guys have did in this line. And this line will add 8 neurons in the input layer and 12 neurons in the first hidden layer. And this line will add 8 neurons in the hidden layers. Okay, this is the second yellow color. And model dot dense of one activation is equal to sigmoid. So since we are using a sigmoid, which is a binary classification, either this or that. Okay, because either you are going to tell whether the person is having a diabetes or not having a diabetes. We are not going to tell, you are not going to tell good, medium, or normal, so likewise. So we're just going to tell this or that, 0 or 1. So that's why model dot add of dense of 1 comma sigmoid activation is equal to sigmoid. So what is mean by that? We guys have added another final output layer, which is going to have only one neuron to make a decision, either 0 or 1. Okay, are you guys are clear with this up to now? If you are happy with this, you just post I'm happy Sanjay in your live chat. So we guys have designed one simple neural network. First of all, sequential, and first input layer with the 8 neurons, and first hidden layer with the 12 neurons, and second hidden layer with the 8 neurons, and finally the output layers with only one neuron by using a sigmoid as an activation to function to make a decision either 0 or 1. And then compilation. So here we have done a compilation of our model, same syntax which we guys have learned before, and it's time to do the training, guys. Okay, now we are just going to do the training. Since the data set is very small, so it is going to complete the training very faster. So model.fit, which is the command to start doing the training. So model.fit of my x and my y, comma epoch is equal to 20, which is nothing but, for an example, if you are having 768 rows of data, so how many iterations you need to carry over that 768 data? So that is what the epoch means. So epoch is equal to 20. It is going to continuously iterate towards 20 times throughout the complete data. And batch size, how much batch it need to take for only one to completing one iteration. So that is what the batch size is equal to 10. So that we the guys have did. Once this line has been crossed, which is nothing but training has been completed, and model dot evaluate of x comma y, so which is going to give me the accuracy of the model, and finally we are going to save the model in our local directory. That is what we guys have did in this program. So I'm just going to run this program. I hope you all super excited to see the output. If you all super excited, just post I'm super excited Sanjay in your live chat. So Python space train.py. Okay, I'm just going to train it, guys. Okay, using TensorFlow as a backend, because Keras is going to use a TensorFlow as a backend, as we guys have already learned that. Girish, no need to attend this live, sir. So you'll get the internship certificate in the portal itself. Okay, no need to attend, sir. Yes, we got an accuracy which is 72.53% accuracy. So this is what, like for an example, epoch is equal to 1, epoch is equal to 2, up to etc. Epoch is equal to 20. So that is what we have given in this program. So in this program, we just simply trained the algorithm. So first of all, I'm repeat the program once again only for you guys. I hope you'll be feeling happy whenever I'm explaining again. So these are the libraries, like NumPy for handling a data set, sequential for organizing layers in a sequential order, and dense, which is going to be helpful for mathematical operation, model from JSON, which is going to be helpful for loading the model. Now we guys haven't used, I think. So, and then we are going to load the data into a single variable called dataset by using a load text library, NumPy's load text library. And now we are going to segregate our whole data set into input and then output. So X is going to be your input and Y is going to be output. So by observing from this data set, this first 8 column is going to be your input and final column is going to be output. That's what we guys have did in the X and then Y. And then model is equal to sequential. We guys are initializing it. And we have added one input layer with 8 neurons and one hidden layer with 12 neurons with activation function, relu activation function. And second hidden layer we guys have added with 8 neurons. And finally, we guys have added only one neuron with sigmoid activation function, because it is going to do a binary classification, either this or that. So that's why sigmoid has been used. And compilation is done by passing a loss function, optimizers, and matrices. And model.fit function, which is going to be giving giving you the training process. So it is going to start doing the training. And once the training is completed, we are going to evaluate the model. What is the model performance? And then finally, we are going to save the model in our local directory in the file extension called .json and .h file. So these two model files which is being saved in my local directory. So that is what the training program is all about. Now, let us explore the test program. In the test program, what we just did is we just use the same program. So same library and same segregation. And here, instead of writing it, you just reading the model file, because my model file, which is present in my local directory, we are just loading the model from the local directory, which is going to be kept in the variable called model. So now we are going to do the prediction. Predictions is equal to model.predict of class of X. So what we are just going to do is, I'm just going to take this 5 rows of data. Okay, I'm going to take this 5 rows of data and I'm going to see how much is right and how much is wrong. So that is what I'm just going to do. I hope you are super excited to see the output of test program. Okay, Python space test.py. I'm just going to run this. So let us see the answer. Okay, so out of 5 marks, how much marks our model got? Just see here. This is the predicted results, but actual results is 0. So out of 5 marks, our model got 1 mark, and our model tell this person is not having a diabetes, but actually the person is having a diabetes. So it is wrong. And our model is telling that this person is having a diabetes, but actually this person is not having a diabetes. That is also wrong. And the person is having a diabetes and the person is also having a diabetes. That is right. So 2 marks. So out of the 5 marks, our model got 2 marks because last one is also wrong. So this is what accuracy we got, which is very, very simple project. We guys haven't gone very in depth on tuning and those stuff. We guys have simply did PMA engines diabetes reduction by using a deep learning simple neural network. With the help of that, we just also designed some very simple neural network, which is having only one input layer and 2 hidden layers on one output layer. So with the help of that, we just classified whether it is person is having a diabetes or not having a diabetes. And if you guys have any project or product related queries, please visit Pantech.net. And if you guys haven't followed me, you can also follow me through the LinkedIn. My LinkedIn link is also given in the description below. Okay, so I hope you guys have enjoyed today's session. If you enjoyed it, you just post I enjoyed. Thank you so much. Jagdishwaran posted I enjoyed. And Israel, thank you so much. And Krunal Patel, thank you so much. So thank you so much, guys. Okay, so thank you so much once again. Okay, wonderful. And Gomati, thank you so much. Okay, so yes, wonderful, guys. Thank you so much for your response. Thank you so much for your positive message which you are spreading here. Wonderful. Salman Ahmed and Priyanka, thank you. And wonderful, guys. Wonderful. And Gulabchan and Niveda and Nagakishan. Wonderful, guys. Wonderful. Thank you so much for giving the positive message. So what we just did is we just did like what is it? It is not a convolution because we guys haven't added convolution layer. It is normal neural network where we guys have done PMA engines diabetes detection by using numerical data from the Excel sheet. We guys have loaded it and we guys have designed simple multi-layer perceptron neural network, and we guys have passed that input into it and we guys have trained it and we got the results. Okay, that is what the 2 program which we guys have given today. So I hope you guys have enjoyed. So thank you so much for making this event to be very successful. And don't miss out the upcoming session because there are a lot of surprise which is waiting for you. So don't miss out any session. So thank you so much. Thank you once again. It's me, Sanjay, signing off. Until then, bye. We'll see you on the tomorrow session.